Introduction. Michael prepares coffee for himself and his friend. He uses 100 milliliter of water, 2 spoons of sugar, 2 spoons of coffee powder and 100 milliliter of milk. How much quantity of each item will he need if he has to make coffee for 10 people? If each ingredient is multiplied by 5, then he can prepare coffee for 10 people. In the same way, we come across similar situations where we see variation in one quantity bringing in variation in the other quantity. For example, if the number of books purchased increased, the total cost also increases. The more you exercise, the more fit you become. Objectives. At the end of this lesson, you'll be able to discuss the concept of variation, define direct proportion, solve the problems under direct variation, recognize inverse proportion, evaluate problems under inverse proportion. Direct proportion. If the cost of 1 liter of milk is ₹9, then what would be the cost of 5 liters of milk? It is ₹45. Similarly, we can find the cost of 7 liters or 9 liters of milk. If liter of milk increases, cost also increases in such a way that their ratio remains constant. Example. Suppose a jeep uses 4 liters of petrol to travel a distance of 50 kilometers. How far will it travel using 8 liters? The answer is 100 kilometers. We calculate the above answer in the following way. 4 liters of petrol to travel 50 kilometers distance. 8 liters of petrol is twice 4 liters. Therefore, 50 into 2 is equal to 100 kilometers. Let the consumption of petrol be X liters and the corresponding distance traveled be Y kilometer. Then complete the following table. Direct proportion. As X increases, value of Y also increases in such a way that the ratio X upon Y does not change. It remains constant, say K. X and Y are in direct proportion if X upon Y is equal to K or X is equal to KY. In the previous example, 4 upon 15 is equal to 8 upon 100, where 4 and 8 are the quantities of petrol consumed in liters X, and 15 and 100 are the distance Y in kilometer. When X and Y are in direct proportion, we can write X1 upon Y1 is equal to X2 upon Y2. Y1, Y2 are values of Y corresponding to the values X1, X2 of X respectively. Example 2. A tower of 50 meters high casts a shadow of 35 meters. Find the height of a lighthouse that casts a shadow of 45 meters under similar conditions. Solution. Let the height of the lighthouse be X meters. We form a table as shown below. More the height of an object, the more would be the length of its shadow. Therefore, it is a direct proportion. We use the following relation. X1 upon Y1 is equal to X2 upon Y2. 50 upon 35 is equal to X upon 45. 50 upon 35 into 45, which equals X. 64.2 is equal to X. The height of the lighthouse is 64.2 meters, or this relation X1 upon Y1 is equal to X2 upon Y2 can be written as X1 upon X2 is equal to Y1 upon Y2. X1 is to X2 is equal to Y1 is to Y2. 50 is to X2 is equal to 35 is to 45. X2 is equal to 50 into 45 upon 35, which is equal to 64.2 meters. Example: an airplane flying at a uniform speed of 520 km per hour. How far will it travel in 45 minutes? Also find the time required to cover a distance of 500 kilometers. Solution: let the distance traveled in kilometer in 45 minutes be x and time taken in minutes to cover 500 kilometer be y. Since the speed is uniform, the distance covered would be directly proportional to time. 520 upon 60 is equal to x upon 45. 52 into 45 upon 6 is equal to x. Therefore, x is equal to 390. An airplane cover a distance of 390 kilometers in 45 minutes. Since the speed is uniform, the distance covered would be directly proportional to the time. 520 upon 60 is equal to 500 upon y. So y is equal to 500 into 60 upon 520. Y is equal to 57.69. Time taken by the aeroplane is equal to 58 minutes. Inverse proportion. Two quantities may change in such a manner that if one quantity increases, the other quantity decreases. For example, as the number of copies of Xerox increases, the cost decreases. Similarly, the number of workers increases, time taken to finish the job decreases. Example: 5 tankers are required to fill a tank in 2 hours 30 minutes. How long will it take if only 3 tankers of the same type are used? Lesser the number of tankers, more will be the time required by it to fill the tank. So this is an inverse proportion. 5 into 150 is equal to x into 3. 5 into 150 upon 3 is equal to x. 250 is equal to x. Time taken to fill the tank by 3 tankers is 4 hours 10 minutes. Example: there are 30 students in a class. The number of tables required for them is 18. If 15 of them are added to this class, how many tables will be needed? As the number of students increases, number of tables required for the class also increases. This is a direct proportion. 30 upon 18 is equal to 45 upon x. X is equal to 45 into 18 upon 30, which is equal to 27. Number of tables required is equal to 27. Summary. Let us summarize what we have learned. Two quantities x and y are said to be in direct proportion if they decrease together in such a manner that the ratio of their corresponding values remains constant. That is, if x upon y is equal to k is a positive number, then x and y are said to vary directly. In such a case, if y1 and y are the values of y corresponding to the values x1, x2 of x respectively, then x1 upon y1 is equal to x2 upon y2. Two quantities x and y are said to be in inverse proportion if an increase in x causes a proportional decrease in y, and vice versa, in such a manner that the product of their corresponding values remains constant. That is, if xy is equal to k, then x and y are said to vary inversely. In this case, if y1, y2 are the values of y corresponding to the values x1, x2 of x respectively, then x1, y1 is equal to x2, y2, or x1 upon x2 is equal to y2 upon y1.